Well, hello there, and welcome to another Minecraft tutorial. In this video, I'm going to show you how to do functions using command blocks from 1.9 and above. Now, for those of you who don't know what a function is, it's basically a set of command blocks that run certain code that you can separate from all the rest of your command blocks. And anytime you want to run that code, you can call the function and it'll run that code arbitrarily, whenever you want, from anywhere, without having to duplicate that code for each chain of command blocks that you want to run it. So the way we used to do functions in Minecraft before 1.9 was we would summon a redstone block. We would set a redstone block next to the block that we want to, or blocks that we wanted to run. And that's all fine, but it doesn't work very well with chain command blocks from 1.9. So the way chain command blocks work is once they've started executing, the entire chain will finish executing before anything else happens in the game. And so what that means is, if, say, over here, I set a redstone block to trigger this, it's going to continue finishing that chain until it's done. And once it's finished, only then will the function get called. And that's not what you want your functions to do. Because, for example, your functions might return a value that you want to use in this chain, and you're not going to be able to because you won't get that value till the chain is done. And so it's a little annoying. So in other words, what you want to happen is you want your chain to stop when it calls another function, wait for that function to finish, and then continue on from where it left off. And you can't really do that easily with chain command blocks unless you get a little creative, which is what I've done here. So, you'll see I have this return armor stand. Basically, this return armor stand is going to have a redstone block set at its position whenever any function finishes. And so at the end of all of our functions, we have this thing, this same command that says we execute on the return armor stand, and we set the block it's in to a redstone block. And this does the same thing, and all of our functions will do that. And this one doesn't, because it doesn't actually have to return anywhere, but it could if it wanted to. So that is the return armor stand. And so what we do is we break the chain ourselves, because we don't want these chains to continue on running until the end. So we break the chain ourselves every time we call a function. And we do that by turning the chain block sideways for each one that calls a function. So this block calls a function. This block right here calls a function. This block right here calls a function. And because we turn them sideways, it cuts off the chain. So it'll get executed, but then it's not pointing into anything, so it'll stop right there. And so then it'll give it time to call the function that we called by setting a redstone block. And then when that function finishes, it'll run that return code. And before we call the function, we actually teleport the return armor stand to the next part of this chain, so that when this returns, it'll return to exactly where it left off in the chain and continue on until the next function call, or the end of the chain. So to show you that in specific commands, so all of these blocks, these impulse blocks here that these armor stands are on, all they do is set the block above them to air. And so what that does is, when we set these blocks to redstone blocks, the impulse command block will trigger. It'll trigger the chain that it's connected to, but then it'll also set it back to air so that it can be triggered again later. So it self-resets. And so what we do, so for example, I made this queue system, Now, I'm going to go over how the queue specifically works at the end of this video, but it's mostly just an example of how useful functions can be. So you don't need to know the details of this yet, but all you need to know is that there is a fake player called temp, and when we call the write function, it's going to take the value that's in that fake player's score, and it's going to write that to our queue. And when we call the read function, it's going to read the value from the queue, and it's going to put that in temp's score. And so temp is kind of our scratch paper that we use to communicate between functions. So for the main function, which is just a bunch of stuff that I put together just to test the function system and the queue, we first set temp to 3, which means we're going to be writing the value of 3 to the queue. Then we teleport the return armor stand to the position of the main 2 armor stand. Now if we look, main 2 is over here, and so what we're saying is we're about to call a function, as you can see by this turn sideways block, and before we call the function, we want to make sure when that function finishes, it's going to resume this chain from this position. So we teleport the return to the position of main 2 by just teleporting it. And then we call the function. And to call the function, all we do is we execute on the function label, armor stand. So armor stand named write, which you can see is that one. So these are function labels. So we execute on the function label armor stand to set a block at its position to a redstone block. Now remember, all of these impulse blocks just trigger their chains and then immediately set the block above back to air. So what we're really doing is we're just triggering this write chain once. So we set the value of temp to 3, we set the return position here, and then we set the write function to a redstone block, so we trigger the write function. And then the chain stops because it points sideways. The write function will, the write function will trigger. It'll do its work. And then when it gets to this return part, where it executes on return to set block, return will be here. So it'll set this block and it'll trigger this chain. Now this chain writes a value of 7, sets the position of return to main 3, which is up here, and calls the write function again. And then we do it again once the write function finishes. Now the return will be up here, so it'll return to here. It'll set the value to 5, and then it'll call the write function again. Now what's important is, if we didn't have this block here, which I'll show you in a second, then when it got to the end here, you would end up with an infinite loop, because the return armor stand would still be here, because we have no other code to teleport it to. So it would stay here, so then it would write, and when it writes, it will return, which will trigger this again, and then it'll write, and then it'll return, and then it'll trigger this again, and it'll just go on forever. So in order to prevent that from happening, before we call the final write function that we're not going to be returning from, we teleport the return stand to this special place called no return. And no return is this armor stand here, and all it is the same thing as these blocks, setting the block above back to air to get rid of the redstone, but it doesn't actually connect to any chains. So it will not run any code, it'll just go there and finish up and be done with the code. And so just to kind of summarize, it'll write the value of 3 to the queue, it'll write the value of 7 to the queue, and it'll write the value of 5 to the queue, and then it'll quit. It'll be done. And for those of you who don't know how a queue works, it's a place to store data. You store multiple things, and the order that you read the data back is the same order that you put it in. So if I put in a 10, a 20, and a 30 in that order, when I read it back, I'd read it as 10, 20, 30. It's not going to sort it. It's not going to change the order. It's just you're going to read it back in the same order you put it in. And so then over here, we have a little thing that calls the read function but this is called the read player because the read function will only read to the temp fake player score. So this function will call the read function in order to get the next value in the queue, but then it'll return back to set player up here, which sets the player's score to the temp value so that we can actually see it on the player, and then sets it back to no return to prevent infinite loops. So yeah, so to show you what all that does, if I click this, we now have this queue. Now the first armor stand in the queue is a null value. In other words, it's a meaningless value. It's never actually read. It's only there to mark the start of the queue, because if you have no data in the queue, and that means there's no armor stands, then you don't know, the command blocks at least, don't know where to start placing armor stands next time you need to write. So this just marks the head of the queue. And then each of these stores one piece of information. And if you look in the sidebar where the scores are, you'll see that one of these has a value of 7, one has a value of 5, and one has a value of 3. Which Minecraft will always show in sorted order, which is why it says 7, 5, 3. But the order that this function actually placed them in was 3, 7, 5. And to show they're in that order, we can now call this read function. I can see where my crosshairs are. And when we press it, we can see now my score is 3 because that was the head, the first value. And then there's 2 more values. The first one was removed. Call it again. Now my score is 7, which tells you that the second value was 7. Now there's one more. You press it again, and my value is 5, which tells you that the third value was 5. And now there are no values left. So if you run it, nothing happens because it never changes the temp value. Now if you did change the temp value and you ran this, it would actually set your value to the temp value, even if there was nothing in the queue. That's just because I didn't put any error checking in the read function. I didn't check to see if the queue was empty or anything. It just sort of does nothing if the queue is empty and leaves the temp value, to what it is. But that's fine. No big deal. If I wanted that, I could add that in pretty easily, especially since this starter armor stand has a tag on it that tells it it's the head, so we can just check for queue armor stands that don't have that tag, and if we can't find any, then we know it's empty and we can work with that. But yeah, so sorry, not trying to get into the queue just yet, but you can see how that worked. So if I press this, now watch carefully at all of the armor stands. It went very quickly, but you could see all of the armor stands moving around. And now there is a 3, a 7, and a 5 in the queue, and my score is still 5. If I run this, it should set me back to 3. Yep, 7, and 5. So yeah, so we have functions. So the writing and reading can be called from anywhere else using this technique without having to duplicate any of these command blocks. So once I've created this function like this, that function is set and can be called from anywhere at any time. So yeah, so this is a good way to do functions in Minecraft 1.9, I suppose. So yeah, it's basically taking advantage of the fact that even though Minecraft won't stop a chain midway, you can force it to do that by facing the last chain in a part, or sorry, the last chain block in a part into thin air, and that'll force it to stop at that position. And then you just, before you do that, you mark where you want it to start from again, and yeah. So hopefully that was clear. I know I was kind of vague in some parts, but hopefully I was clear. If there's anything you don't understand specifically, just let me know in the comments and I'll try to explain it a little better. But yeah, hopefully people take advantage of this in their maps because it's extremely useful for organization. Yeah. So now it's towards the end of the video, so I'm going to explain a bit about specifically how the queue works. So again, the way a queue works in computer science is it stores a bunch of data, and each piece of data that you read comes out in the same order that you wrote it in. So the way I'm doing that is with armor stands, and I'm literally keeping them in order in a line. And it doesn't have to be this way. You can use a scoreboard value to indicate the position. So like if the score is 0, then it's at the head. If the score is 1, it's the next one. If it's 2, it's the next one. You could do that, and then they could all stay in the same block, but it's not as visually appealing, and for demonstration purposes, I figured I'd just leave it like this. So the temp value, I believe, is 5 right now. If I click this, then I can, write as many 5s as I want. And so what's going on here is the write function looks for the furthest Q armor stand from this block. Now keep in mind these are right next to the block in the x-axis, so the farthest one will be at the end of the line. And the way it looks for the furthest, in case you didn't know, is by using this c equals -1. So the c is a count parameter, and usually you do stuff like c equals 2 to find the nearest 2, or c equals 1 to target just the nearest entity. But if you use negative values, it'll find the furthest entities instead of the nearest. So you can use c equals -1 to find the farthest Q armor stand from this position. So we execute on that. So we execute from that position, and we summon a new armor stand 1 block away in the x direction. So that'll be right behind it. So we're summoning a new armor stand with a custom name Q behind the last armor stand with a custom name Q. So we add it to the end of the line. And we give it this tag called new. And the reason we do that is because unfortunately there's no way to set a score in the same command block that you summon something. So instead we're going to summon it with this tag of new so that we can find it later in the next command block and target it. So what this does is it uses the scoreboard player's operation command to set the Q armor stand with the new tag, which will only be the one we just created, and we'll set its value to whatever's in temp, which is our scratch paper. And then we just remove the new tag from all Q armor stands because we've just now set their values, so they're not new anymore. So we remove the new tag, and then this is just the return code I showed you before, which just sets a redstone block at the position of the return armor stand so that when it finishes writing, it goes to the next part of the code, if there is any. So yeah, so basically like if I were to write one now, it would target this one, this armor stand, because it's the farthest from that block, and then it'll execute on here to summon a new armor stand over here in this block, also called Q, but with a new tag. And then it'll find the armor stands with the new tag, which will only be this one, and it'll set its score to whatever's in temp. And so it'll write that value to the Q. And then when we read, which in this case we're reading back to temp, but not writing to the player, because that's actually this function here. So we're just reading to temp for the other functions to deal with however they need to. So what this does is it first sets the temp value equal to the value stored in the closest armor stand that does not have a tag of null, or the closest Q armor stand that does not have a tag of null. And so the reason we do that is, remember I said that this armor stand is not actually part of your data, This is just to mark the start of the queue. And so the way we do that is by giving it a tag called null. So this will always be the nearest armor stand to this block, so we have to skip it by choosing the ones that don't have a tag of null. And then we choose c equals 1, which is the nearest one, so that'll be the first one you put in. The oldest one still in the queue is the one that we're targeting. And we're copying its value over to temp. And so that is the reading part pretty much done. But with a queue, after you read something, you generally remove it from the queue. And so to do that, we kill that armor stand. The same selector to get the same armor stand with a c equals 1 and tag is not null and name is q. We kill that, so now it's gone, it's deleted. And then we teleport all of the q armor stands, except the null, over by one block. Because let's say you have one here, and one here. If you read it, this one's going to go away, and then these two will actually be a block away from where they should be, a block away from the start of the queue. So we just teleport them all over by one block to move the queue up. And that's pretty much it. And then this is just the return again, so that it returns to the other code. And yeah, that's pretty much it. Now, I was thinking of using this queue to create a sort of flood fill, because if you have a queue, you can do breadth first search. You need a stack for depth first search, but to be honest, the only difference between a queue and a stack is the direction it reads from. So it's not going to be, it wouldn't be too hard to turn this into a stack. But yeah, so you can do breadth first search with a queue, and breadth first search is a way to do a flood fill. So I was thinking about doing a flood fill with this queue system, but I don't know. Let me know in the comments below if you want to see that. I'm probably going to play around with it a bit. If it gets too tedious or too hard, I won't. The hardest part of that is just going to be keeping track of each individual armor stand, or each individual block that we're trying to search through. But anyway, that is completely out of the scope of this video. So I'm going to stop talking, and I'm going to say that hopefully this helps you. Hopefully we'll see it in some other videos, in some other maps, in mini games, or what have you. Hopefully this is a useful technique for creating functions. So until next time, keep calling your functions, keep returning to the program, and keep redstoning. That was the nerdiest outro I've ever done.